Hello everyone, for this tutorial video I'd like to talk about multivariable differentials, which uses similar logic to single variable differentials, except the formula looks more complicated. We remember from Calc 1 that one interpretation of the differential is the net change, as in when we compute integrals with respect to the differential. So we will use this interpretation to justify the formula for multivariable differentials. In particular, we remember that the differential for a single variable function is change in y equals the derivative times change in x. For multivariable functions, it is a little more complicated and looks like change in function or change in z equals the partial derivative with respect to x times change in x plus the partial derivative with respect to y times change in y. And if we had a three-variable function instead, we would add the partial derivative with respect to the third variable times the change of that third variable. It may seem arbitrary or random that we add the two partial derivatives rather than something like multiplying them, but if we remember from how integrals work, that the differential can be thought of as asking for the net change of a variable, it makes it a little more clear why you would add the partial derivatives, because it is the net or total change of all of the function's inputs. Now that we have seen how differentials work for multivariable functions, we can talk about how the chain rule works for multivariable functions next, which actually uses a similar formula to multivariable differentials, i.e., it is an addition of different partial derivatives with respect to different variables. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.